Good evening, everyone. With great pleasure, I welcome our first speaker for Protolith 2020, the webinar segment, Professor Gerta Keller from the Department of Geosciences, Princeton University. Professor Keller is well known for her research contributions to the Cretaceous-Paleogene boundary mass extinction debate. Her work has single-handedly challenged the popular Chicxulub-Bolide impact hypothesis. Professor Keller's exhaustive database and meticulously built over the past 3 decades firmly links the end Cretaceous crisis to paroxysmal pulses of Deccan volcanism. Let's hear more about mass extinctions and dinosaur wars from Professor Gerta Keller.
Well, thank you, Janvi, for your introduction. I will talk today about the dinosaur wars and whether it was an extinction by asteroid or by volcanism. And in the end, my question will be, are we the next dinosaurs? So, at first, let's start with the impact theory. 66 million years ago, an asteroid crashed into Yucatan. In an instant, caused a mass extinction of the dinosaurs and about 75% of all other life forms in global wildfires, followed by darkness and a nuclear-type winter. That's the impact theory that ruled as the sole cause for the fifth mass extinction in Earth's history for the past 40 years, tolerating no evidence to the contrary and eliminating any opposition within the first few years. From the very beginning, the media loved this sexy story. The public loved it, and many scientists jumped on the bandwagon for an easy ride to fame. But it was the most nasty controversy. It tolerated no alternative hypothesis, silenced and eliminated any opposition by bullying, name-calling, ostracism, attacks on the integrity of scientists. It prevented publication of evidence contradicting the theory, destroyed careers of those still questioning the theory, and created a silent majority of scientists doubting the theory, but were afraid to speak out. I will tell the story of the dinosaur wars as one who was in this nasty controversy from the very beginning, and despite all opposition, searched for the truth, what really killed the dinosaurs. It is a story told of facts and lies. The dinosaurs' wars followed a pattern of great controversies described in The Structure of Scientific Revolutions by Thomas Kuhn, and The Trouble with Physics, a more recent book by Lee Smolin, 2006. Both of them are fantastic for any students of science to read. What they're telling us is, number one, scientists in these controversies, scientists lose a perspective in science and believe in the rightness of the hypothesis or theory. Then they progress from fact-based to belief-based interpretations, which I call truthiness. Then the third part is the controversy escalates into heated arguments, accusations, and acrimonious personal attacks. And then, by the end, new discoveries support alternative hypotheses and require modifications or the exit of this theory, of the controversial theory. The dinosaur wars follow this common pattern in clearly defined 4 phases described in Kuhn and Smolin. It is first phase, the hypothesis, which for the dinosaur wars was the iridium and the mass extinction. In phase 2, it's the theory, and that became the iridium and the impact crater. In the third phase, it's the crisis phase, and that is the pre-KTH of the impact. And the last phase is the emergence of alternative theory, and that's Deccan volcanism. I will leave all this aside now because it will take me too long to point out where we are entering each phase and for what reason. So I have a lot to cover, and so we will march ahead. This is for a brief introduction. We have 5 major mass extinctions in Earth's history. All of them have associated large igneous province volcanism, including now also the late end Ordovician mass extinction. Even though we do not have the location of this kind of volcanism, the mercury concentrations are there. And then, of course, at the very top, we see I've added the 6th mass extinction, and we will get to that one late at the very end. The dinosaur wars, the nastiest feud in geosciences to date. It began in 1980 with Luis Alvarez, the physics Nobel Prize winner, and his son, a geologist, Walter Alvarez. It's the discovery of the iridium concentration in a thin clay layer in Gubbio, Italy, essentially where Walter Alvarez's hand is touching. Iridium is common in asteroids and in Earth's core and mantle in the same concentrations, about 600 parts per billion. Iridium anomalies associated with impacts and plume volcanism, such as Hawaii and Reunion, are about the same. Alvarez et al. Believed volcanism is too slow to account for the observed iridium concentration, just because volcanism putters out over a very long time. But he was wrong. So the hypothesis they put together is that the large asteroid hit the Earth and caused the dinosaur extinction along with about 75% of life forms, resulting in that nuclear winter type scenario with climate cooling and global wildfires. Both nuclear winter and global wildfires were soon disproved. What they needed was another fact at that point, and that is that the mass extinction in fact did occur. And enter then the graduate student Jan Smith at the time. He claimed that planktonic forehands prove the asteroid is the sole cause of the mass extinction, and that there are no survivors except one species, giving rise to the subsequent evolution. He got this published in Nature about 2 months before, or several months before, the Alvarez published their impact theory hypothesis at the time. Smith's proof was fiction, pure fiction. He lacked the evidence of an instantaneous mass extinction, but simply made it up, and he claimed it was truth. This fake truth became the basis for the Alvarez impact mass extinction theory, and still is today. Smith became Alvarez's postdoc and lifelong, loyal, fierce attack bully against anyone daring to question the mass extinction and impact theory. Below you can see what he made up. It is essentially a group of supposedly 65 species where he simply has line over one block. But he never had any data. He claimed that the data was in his PhD thesis, which I examined very closely and didn't find. There was no data. At that time, I avoided joining the mass extinction studies for the KT for 5 years because I didn't want to jump on the bandwagon. But the real mass extinction, which I analyzed at the LCAF stratotype, is complex, selective, long-term, and associated with environmental changes. And that essentially you can see in this figure. You have the large species dying out. At first, they're the complex tropical species. A group of smaller ones are survivors, not very long survivors, but perhaps 50 to 100,000 years. And then the evolution starts almost immediately after the KT boundary. So, the question is that within 2 years, Luis Alvarez declared that the impact hypothesis had now evolved into a theory, and everyone believes it. And the question I have is, how did this impact hypothesis evolve within 2 years into unassailable truthiness, where real truth and factual evidence could be dismissed by common phrases? Everybody knows that an impact caused a mass extinction. Only old-fashioned Darwinian paleontologists can't accept that the mass extinction was instantaneous. Paleontologists are just bad scientists, more like stamp collectors. Criticism can be dismissed on grounds of general incompetence. All of these are accusations by Luis Alvarez. And then there is the last one. It must be true, because how could so many be so wrong for so long? And those were things that I was given by anonymous reviewers of my papers. They could not simply believe that there was data that did not prove the impact. So by 1991, the smoking gun was found. It was the impact crater on Yucatan, a buried structure claimed to be precisely at the KT boundary impact crater. The problems were there was no evidence of the crater age. There was no evidence this was an impact crater at that time. No evidence that the crater coincided with the mass extinction. Nevertheless, the impact theory was now claimed to be proven beyond doubt. So, evidence for this impact would come from impact spherules. And that was a blessed discovery, because now it started a frenzied hunt for the evidence of the impact crater. And it had revealed these well-dropped glass spherules, approximately 5 to 14 meters below the mass extinction in northeastern Mexico. To support the impact theory and the smoking gun crater, the age of these glass spherules had to be precisely the age of the mass extinction. So how could you explain the 5 to 14 meters of sediments, often just normal marine deposition? Smith came through with the perfect explanation for the impactors. He proclaimed that giant impact generated a mega tsunami that deposited all these meters of sediments between the impact spherules and the mass extinction. So everything was solved. And so the impact theory was modified to include a giant tsunami to explain the glass spherule evidence of pre-mass extinction age, and later on, just about everything that could not be proved. But there was no evidence of impact-generated tsunamis at any time. So, that impact-generated tsunami deposit became unraveled once my small team at the time started to look at these deposits in more detail. It was the time when, for a lone woman scientist battling impactors for truth, to give up the battle. And I was about to give up. But at that time, Charles Officer, who was being crucified by the impact guys, particularly Luis Alvarez, he urged me not to give up on daily phone calls and to lead a field trip. And I did eventually. And what we found was there were no tsunami deposits. There's the sediment deposition deposited in normal marine environments, teeming with burrowing sea life. And that could not be reconciled with tsunami deposition. 3 to 4 volcanic ash layers mark the fallout from local volcanism. And that occurred again during the so-called tsunami event, which is again impossible. You can't have a tsunami event over hours to days and have several volcanic eruptions. Multiple spheral layers were found meters below the mass extinction, and that again could not be reconciled with the tsunami or the age of the impact at the KT boundary. And then there was the limestone layer between two spheral layers that marks the separation in time. It was also burrowed with impact spherules in the burrows. Again, it could not possibly account for a tsunami deposition. So no evidence supports impact tsunami deposition. True evidence was denied, dismissed, and ignored. So this is the time when I had to start my little team. And as you can see, it was very small. There were 2 students, a graduate student at the time, Sigal Abramovich and Alfonso Pardo. And my team consisted mostly of Wolfgang Stinsbeck and Thierry Haddad. And then some that were operating labs, and Jerry Baum, who helped me with drilling. So we were small, but we were a powerful team very soon. Over the years, we accumulated over 300 KT localities. And what you're seeing here is yellow dots and red dots. All of them are KT boundary sequences. The ones with red dots, though, are marking localities with Mercury fallout, and I will get back to that at a later time to tell you why. Primary impact spheral layers in northeastern Mexico essentially reveal the Chicxulub impact predates the mass extinction. So what you're seeing here is at the top of the impact spheral layers, and still underlying a sandstone for that matter, and several meters above is the KT boundary. But when you look at these, there is this one impact spheral layer below it, and then there is another one very much below, up to 13 meters below, 7 meters below, and in between there is just ordinary deep sea marl. Deposition occurred at about 500 meters. So obviously the impact occurred much before the KT boundary. So impact theories attacked, denied, ignored all evidence, insisting the Chicxulub impact tsunami generated all of these deposits. So then there was the mystery of the vanishing Yucatan cores. It was about 1994 when the impact guys were meeting in Puerto Vallarta to discuss how they could drill into the crater in order to prove once and for all that KELLER was wrong. I was invited there because NSF paid for the meeting, for this workshop, and I guess they had to invite me because they needed at least one person in the opposition. So, as I was at that meeting, I wondered myself, what the heck was I doing there? Because here I looked at a big crowd of geologists drinking beer in this beautiful hotel in the lobby. And I was standing still up on the steps, the curved round steps going down into the lobby. And I overlooked them, and I thought, what the heck? What am I doing? I stood there, and there is one of these men, the elderly gentleman, is stepping out of the crowd, coming up to look up at me over the steps, and he has 2 drinks in his hands. And he said, "You look like you could have a drink." And I said, yes, and I was laughing, and I went down, and I said, I introduced myself, I'm Gerda Keller. And he says, yeah, I know you. And then, and I said, and who are you? And he says, I'm Bill Ward from University of New Orleans. What were you thinking? He asked. And I said, I was thinking, what the heck am I doing here? And he laughs and he says, I was thinking the same thing. And I said, so why are you here? And he said, it's because they invited me to bring the course, the PEMEX course. And I said, what? They were destroyed in a warehouse fire. And he said, who tells you that? And I said, well, all the impactors have made up that story. And he says, it's untrue, because I have them. Because the person that worked for PIMEX as a consultant had left them it was my predecessor who left it in my lab. And they invited me here so I would give them the course. So I said, how can you do that? Now that they have resurfaced, you and I should work on these before you give them over, and then we will know what happened. So that's what we did. And this is the correlation of it. We looked at all the cores, and we found that, first of all, there were Maastrichtian sediments above the impact breccia in several of them. And secondly, there were the other cores, of course, as you can correlate here. We had more or less undisturbed sediments also below the core. So we published this in 1995. And of course, the impactors did not like that. So, more evidence came from fieldwork, field trips that I took with my students every year to Mexico. And I introduced them to all the outcrops and why the impact tsunami was wrong. And one year, it was about 2000, I had a number of students, a very good class, and I was giving them, this was a 10-day field trip, I was giving them a day off to go to the beach. And they came back and said, we don't want to go to the beach, we want to see whether you are right, and we can find the primary impact sphere layer. So we took them out, and I told them behind one of the hills to start digging down. And here is where they dug down, from the very top to the bottom. And it took 7 meters to the bottom when they found a 2-meter thick impact spherical ejecta layer. And this was absolutely fantastic. Everybody was jubilant. So here are the reworked ones at the top that were known previously and separated by a limestone layer, and then the so-called tsunami, and then the mass extinction above. But now we found 2 meters of pristine impact spherules, 5 meters even below the first layer, 4 to 5 meters. So this is what the spherules look like in thin sections, and the best thing you can see here is that there were no sediment, no quartz, no reworked material anywhere in between the spherules. It was simply infilled with calcite, calcium carbonate. And that meant that they settled immediately through the water column. And some of them settled at the beginning, in fact, as very hot glass spherules that rained out of the sky onto the ocean surface and immediately compacted and became kind of these welded 10 centimeters thick rafts that quickly sank to the seafloor. Well, we could also take all the samples here and see what the mass extinction looked like. Well, this is the 2 meters thick impact spheroidal layer where we have obviously the mass extinction is preceded at that time 160 to 180 thousand years. Now it is more around 200,000 years. But as you can see, all the species went right through this, and there is not even an abundance change. In other words, nothing happened. But when you come to the mass extinction above, this is the submarine sandstone complex, which they want to call the tsunami event. And above that, in the sediments, you can see the mass extinction really starts and has its end. So, this was not a paper that anybody wanted to see. And we sent it to three journals, and each one rejected it. Because we had, for each journal, they were the same reviewers. It was Jan Smith and Peter Schulte. And they had, I don't know how they did it, but somehow they managed to persuade the editors that what we were saying was all wrong, and that there was really a ball and pillow structure. As you can see here, this is their illustrations that they sent to the editors. That all the spherules sort of sank down to the layer where we had the pristine one, and it spread out over hundreds of meters that we could follow. It was all nonsense. But we eventually got it published. So, next came the Chicxulub drilling in 2001 to 2002, and it was supposed to reveal the impact's age and the impact, and essentially we have announced that the impact predates the mass extinction. So, let me tell you, this was the EGU conference, the very first one in these. What we see here is the cores that were drilled with Chicxulub. What you see is, this is a 50 centimeter, that's the impact breccia, the marls, very finely sedimented with slightly waves from the seafloor, and then very thinly laminated, but also a lot of glauconite. In other words, of course, Jan Smith claimed that the sole cause of the mass extinction was the impact. And he called this, again, a tsunami event. But there wasn't any evidence. And we presented them with essentially 7 different evidences. So, I will show you what those were. The first evidence was, of course, the age. The magnetochrone was for the Maastrichtian, followed by the Cretaceous, as you can see here. The second part was the biostratigraphy, again, which was very clearly correct. The third one was, of course, the sedimentology. The fourth one was, the third one was the sedimentologies with burrows. Let me go back to that. With burrows and also the glauconite. And then next was the delta C13 data, which was characteristic Maastrichtian, and then the mass extinction and the evolution. So once I presented this after Jan Smith presented his, and the results went viral with global media cover. Major upheaval puts the impact theory in crisis, and then it began the most nasty dinosaur war. BBC Horizon made a documentary in 2000, which aired in 2004. So we still had the Vanishing Chicxulub cores. And first was the Pemex cores across the Chicxulub crater. And those that were supposed to have burned in a warehouse fire. But NASA had the soil samples and nobody could ever test it until I met Peter Bill Ward, and we studied them. Then we had Chicxulub, the UNAM core, which was drilled by the University of Mexico. We had the samples and we studied them, but they kept back the 50 centimeter interval, and that core completely disappeared. Why did it disappear? Because it would have proved that the impact predated the KT boundary mass extinction. And then 2002 was the Chicxulub core YAX-1. It was a continental drilling that essentially was the result of the talk at the EGU meeting. But what happened there was scientists had to come to Mexico City, to the University of Mexico, and choose their samples, mark their samples on the cores. By the end of the meeting, the critical core, the 50 centimeters that you show here, disappeared. And so pandemonium broke out. And the doors were locked, and everyone was starting to search frantically. And guess what? They found the core in Jan Smith's duffel bag. He was going to abscond with it. And then the next one was the re-drilling of Chicxulub in 2016, just a few years ago. There, it is not that the core disappeared. It is that nobody can see it, that is not part of a small group of impactors that has the only permission to study them. So, after that, it was time to look at Deccan volcanism, the other catastrophe associated with the mass extinction. For many years, Vincent Cortillo, who had worked in the Deccan traps for over 15 years, would ask me, "Gerta, when are you coming to India and tell us where the mass extinction is in the Deccan traps?" And I would say, "Whenever you find marine rocks between lava flows, I'll be there." In 2007, Vincent called to tell me they had a potential site in Rajamundry, and that began our Deccan research. I now had to put together another team. And as you can see, much of it was of Indians. There are 8 Indian scientists here and a couple of my Western collaborators. The first one that we studied was the Gauripatnam quarry in Rajamundry. And after that, we added many more, as you can see. And we studied also many other localities throughout India. So in between the Gauripatnam quarry, you can see that there is a fairly thick sediment unit that was deposited right after the KT boundary. And it is in between 2 lava flows. That meant that the KT boundary mass extinction occurred right in between lava flows. This is the first documented evidence. And it was fantastic. But the best mass extinction, in fact, we found in Meghalaya. And that is even more fantastic because we could have virtually everything about 700 kilometers from the Deccan volcanic province. I will not go further into this because we have a lot of sequences here, But after we did all the Rashomundry studies, and many Indian scientists have also studied these and confirmed these marine deposits. Meghalaya was up here, and we were looking also at different localities like Chilmeli and Kutch and the Kaveri Basin. The problem was that we could not find sequences with sediments below and going all the way through the Deccan traps. So that was really where ONGC drilling came in. I needed to see those cores, and everybody was telling me, you can't get them. It's a very top secret core library. Nobody has access to it. So I invited myself to Dehradun, to their headquarters, to give a talk. And I gave a talk, and they permitted me access to the course. I will not go into details, but this is what we got out of studying 9 of the ONGC wells together. You can see that these are the lava flows below the boundary, and then there is a second group that is in the Danian. We will concentrate on this one. What we saw that is that even after the first lava flow, most of the species disappeared. And after that, there were just a couple around species. In other words, the mass extinction had already thrived. All you needed was one single major lava flow in Rashomundry. So, the question here was, where is the mass extinction in the Deccan traps? Just as Vincent Cortio asked. In order to get a handle on that, we needed to have some UPV zircon dating. But no one has ever succeeded to do it. And I had a postdoc try to do it based on the basalt flows, and it wasn't any good. It was almost 2 years wasted. So now the question was, where could the zircons be? Because every volcanic eruptions of lips nature has zircon crystals. And so I thought, okay, it has to be in the red balls, between lava flows, because there is nothing else. And so I made my trip down to my second floor to my colleagues. My colleague, Blair Schoen, and who has a fantastic, up-to-date UPB geochronology lab. And I told him, I'm going to have a proposition for you that you can't deny. I think we can find zircon crystals in the red balls in the Deccan traps, and we can get the age for it. And if we are right, then your career will be made. And if we are wrong, then you have a vacation, because I'm going to pay for your trip with my funds. And I said, you can bring 2 students, and here are the 2 of them. So this is my team for the Deccan dating. Thierry Haddad and Syed Kadri, who's been working with us all the way through India, and is an IIT graduate, by the way. And then these 3 guys for UPB dating. We were successful, even though all of them were very, very negative in the field and said, you are wrong, it's never possible to have zircons in the red balls. But when they got back and went to the lab and washed the red balls, they found them. And pretty soon we had fantastic ages. So this was in 2019. The age curve for UPB dates shows that you have essentially eruptions, very rapid eruptions, and then slower parts. And these were the eruption rates. This is the 2019, the first paper was in 2015 with our first dates. Now, also of course, this brought in some argon dating from Paul Rennie's group in Berkeley, and of course the argon dates had to confirm with the Chicxulub impact. And so what he did is essentially, as you know perhaps, the brown curve here is our UPB dating curves by age. The KT is around here at this particular part. But for argon dates, you get only, the error margins are so large that all you can get is essentially a continuous curve up. But the probability of stratigraphic position of the Chicxulub impact based on argon is anywhere from the Kandala Otaku Wadi Formation up through the Pollard Pool. But the probability for the UPB is only at the top of the Pollard Pool and below the Amdanali. So this is where we are today. So next we needed still something more. We needed another idea as to how could we actually identify the Deccan traps eruptions in the global sequences. And for that we got the new tool, Mercury fallout from Deccan volcanism, which is a new tool for evaluating age, climate, and environmental effect of large igneous provinces. So here is what we got. The first discovery was by Sani and Steve Grasby and Bursham in 2012. They did it for the peak Permo-Triassic mass extinction. So this is their cartoon for it. We have the major dip eruptions. They bring the mercury into the atmosphere. Mercury has a residence time of 1 to 1.5 years, and then it rains out. During that time, of course, it gets distributed throughout the world, and then it falls out and eventually rains into the sediment, washes into the deep sea and into sediments. Now, if you measure these, then you should be able to identify the volcanic eruptions. So that was the idea. So we tried this through many other sequences. As you can see, all the red dots here are KT sequences where mercury fallout from Deccan eruption has been identified. So, what we wanted was not just an eruption for the KT. We wanted document the entire Deccan volcanic eruption sequence. And the only way we could do that was to identify, to go to sequences with very high sedimentation rates, and a complete one. And that was at Ellis in Tunisia. And then we needed a confirmation that this was really true. So we went to Israel for another sequence. And then we would tie it to the Deccan traps. So this is what I can show you now. Climate change. At the LS sequence, we could measure the climate record from Blanctic and benthic foraminifera, the mercury sequence, of course, the total organic content, and we also had this very detailed cyclostratigraphy for age dating of the land sequence. Now here, for a quick, you can see that there is a lot of delta 018 starting with a lot of fluctuations here in Cron 29R, near the base of zone CF2. But most of the Deccan traps is starting around down here around 355,000 years before the mass extinction. And it is rapidly warming. And then by the top, last 25,000 years, it is hyperthermal warming with huge eruptions. And that's what you're seeing here. Each of these peaks are the main peaks, and this is a 3-point average, but the actual peaks are given in these numbers. Jigsaw impact coincides approximately with this interval, and based on our age dating. And the hyperthermal warming is essentially in the Rajamundry longest lava flows, all the way to Rajamundry. When you try to look at it, how to correlate with Hor-Hahar, which is this particular one, versus the one at LS, you can see they're virtually the same. This is the one with Chicxulub impact, and this is the hyperthermal warming, and we have all these other peaks that you can identify. So we had actually a eureka moment here. We can actually identify every major volcanic eruption that happened in the Deccan traps. We can find in any deep sea sediments. So next we needed to actually prove this, that these could be correlated with the Deccan traps itself. So here we have the LS record with all the peaks, and they're numbered, and each event is numbered from 1 through 20. As you can see, for the hyperthermal warming and the longest lava flows, it's E12 to 20. We have 8 of these major lava flows, or major eruptions, I should say. Now, we had very good UPBHs, as you can see here, and we can correlate each one of these to the right peaks, which we also identify in the cyclostratigraphy. So we confirm that we can actually identify every peak in the Deccan traps based on UPB dating and based on orbital cyclicity in the LS section. And then at the end, what caused the long-term climate warming and long-term environmental stress? So how did this happen? This is the climate curve. From cooling, starting with the warming, and of course the surface acidification event. And it starts already below and it continues into the hyperthermal warming. The warm event here is only present in very rare sections, like here in the LS, where sedimentation is 7 to 8 centimeters per 1,000 years, and we analyzed about one sample every 1 to 2,000 years. So, oh yes, and then of course we have the forams. The major changes in the forams are already related to very early on with the onset of the Deccan traps. And as you can see, we have Cumulatory Cretaceous is essentially still pretty happy, but this disaster opportunist and the only survivor for 4 amps is getting very abundant as the catastrophe is, or at least the hyperthermal warming starts, and also the decrease in the faunas thanks to this warming. Now, the one thing that I should mention here is that in the sequence that we analyzed, it is criticized because there is no hyperthermal warming in the Atlantic deep sea sections that impact folks always use to prove that the Chicxulub impact caused major cooling, namely this major cooling here. And in all of those sections, there is a KT hiatus because this interval is not present. So, we analyzed this sequence for ODP 1262 in the South Atlantic as one example, and compared it with LS. And what you're seeing is that LS, we have the hyperthermal warming, but it is not present in the South Atlantic. But the warming is here, and then it's the cooling, and the cooling essentially marks with this part here. So, what we now know is what really killed the dinosaurs. And that is indeed the hyperthermal warming and Deccan volcanism rather than Chicxulub. Is that a surprise? No. Now I want to take a quick turn to the 6th mass extinction and ask ourselves, are we the next dinosaurs? It's quite likely, and perhaps even most likely. So, since the beginning of the Industrial Revolution, the burning of fossil fuels and extensive clearing of native forests has contributed to a 40% increase in atmospheric CO2 from about 280 to 405 ppm in 2018. Temperature increased by 2.4 to 2.8 degrees, the sea level rose 20 to 60 centimeters, our climate change accelerates each year, and hyperthermal warming, ocean acidification, toxicity is becoming common. Famine, pandemics, and wars are likely our undoing by 2050. Now that does not sound very promising. I'm hoping that I can survive until then. I would love to, but it's not likely. But for you, on the other hand, you will be surviving and will know what it is like. So, this is what we have today, and it will get worse. We already are entering famine. We are already entering severe droughts, severe floods, and storms. So this is then what we will get: famine, pandemics, and wars, which likely our undoing. And I would call that the end. And perhaps this is the evolution to our next stage. I love it because it imitates my pets, tortoises. Thank you for listening.
Thanks, Gerta, for that amazing talk. I have heard bits of this many times, but it's always a pleasure to listen to you speak. Thank you very much for agreeing. to give us this talk, because students from all over the country would have tuned in, and this would be very nice for all of them.
Yeah. How do you like my last one?
Last one,
Do you remember these pictures? It was on that France trip.